So here we have these two stations X and Y, and I'll schematically draw out the situations. So A travels from X towards Y, B travels from Y to X, and at constant speed. So we're told train A reaches Y in 10 minutes. So I'll call the speed here as S sub A, and this is S sub B. So if the distance is D, our first equation is that speed of A times the time, 10 minutes, is equal to D. Now we're told that this train A reaches station Y train B takes 9 minutes to reach station X after meeting train A. So let's say that happens at this point where A and B meet each other. So then B will take 9 minutes from that point to reach. The question is asking for the total time it takes train B. So let's say if this is the time T it takes train B to reach the meeting point, then what we're looking for is T plus 9. And here, if it takes them T minutes to meet each other, then the condition would be they would travel a total of distance D in the time T that they can both travel, because they're both traveling towards each other. So that would be the distance covered by train A, and then distance covered by train B. So that's our second equation. Then we also know that train B takes a total of T plus 9 minutes. So speed of train B times T plus 9 is D. So these are our three equations. And we can immediately get rid of D. We can first equate these two. And our goal is to get to T. And I can equate these two. And I can factor out a T here. So you'll see that to get rid of these speeds, I can create the ratio. For example, SA over SB is T plus 9 over T. Actually, I'll do it the other way and you'll see why. Because I can create the same ratio here by dividing both sides by S speed of A. So that would be 10 over T divided by S speed of A, and this will become 1 plus SB over SA. And that's exactly what we can substitute here so that we end up with an equation for T. So that's what we need to solve. This will be a quadratic, as is often the case with these types of questions, and it's actually faster to use the answer choices. Now, of course, if this was a type in the answer choice question, then you will have to solve this. So what we can do is we know these answers are T plus 9. So we can start, let's say, with A. That means that T plus 9 is 15, which means T itself is 6. We plug that here and check if that works. And if we do this, this is 5/3. And that's 2/3. So 1 plus 2/3 is indeed 5/3. That works. And that means that is the answer. Now, of course, the order will be different in a different exam. So it may be a little bit of a trial and error, but I know from experience that it takes less time using the answer choices for this as opposed to doing the algebra and getting the quadratic equation. I mean, of course, we can do the quadratic here as well. And let me see. Maybe it's not as bad, but so let me try to do it quickly. T plus 9 minus T would be 9, and then you'll get T squared plus 9T, and that's the quadratic. Maybe it isn't too bad. And then this would be 15 and 6. So that would be T plus 15, T minus 6 is 0, and we're looking only for positive solutions. So T is 6, and then make sure that you answer what they're looking for, because C is there. That's the trap answer. So in this case, T plus 9 would be 15, and we get our answer.